So the discussion topics and how I've organized this webinar is first to discuss what is blockchain technology, basics of how it works, what purposes does it serve, and then finally end on the cryptocurrencies and how they relate to the blockchain technology. What is blockchain technology? So the phrase that stuck with me while I was preparing for this is the phrase, a distributed ledger system. So if you think of a ledger, accounting ledger, or system of records, excuse me, this is a means of creating a ledger system that's distributed among all a network of parties, which in this case are computers on a network. As we go forward in the future, more and more of our property is digital instead of being physical. Questions arise as to how do we validate ownership? How do we track change in ownership? How do we avoid unauthorized copies of digital product? And how do we avoid fraud? Now, how do we conduct financial transactions securely across the globe in real time with real-time information? You know, a couple of the issues that come up with that kind of a thing, particularly when we're going through our typical financial intermediaries, is the concept of double spending. You know, you spend money here and you spend money someplace else before they realize you've already spent that money. You know, that's no good for somebody. How do we conduct global financial transactions with unknown counterparties with instant and secure closing? You know, if we look at some of the online stuff as we are all locked in our home cocoons in the last several months, and we're doing more and more online shopping with probably more and more distant vendors, you know, how do we conduct those financial transactions with broader parties that we have no idea who they are, without taking the risks that some of us perhaps are taking now? We've all, I don't know about you, but I've certainly received my share of stuff that isn't quite what I ordered, or perhaps didn't receive it at all. And so how do we conduct these global financial transactions with unknown counterparties, getting instant and secure closing on the transactions? And then how do we create and maintain a secure audit chain in a digital world, tracking digital chain of ownership, chain of title, chains of transactions? So what is blockchain technology? To accomplish this, blockchain technology is an attempt to, is a solution really to these issues. Ultimately, maybe not a perfect solution, but that may be impossible to achieve, but it's a very effective one. So you have a network with indeterminate number of nodes. What's a node? A node is an individual computer on a network. Terminology they use in blockchain and in other networking uses is node. Each node tries to earn the right to add the next block of data. So the data in the chain is added block by block. You start with one piece of data, you add the next one, then you add the next one. Each node tries to earn the right to add the next block, and I'll get to that in a minute. Once the next block is added to the new chain, updated data chain, is communicated to the entire network that are participating in, all the nodes that are participating in the blockchain. And interestingly enough, nodes can come and go as participants in a given blockchain, because once the additional block is added to the data chain, it's communicated to everybody that's participating. Information is only added in one direction. So once, if you think of the data as a link in the chain, once that link is added, it can't be taken off. There are various methods for fixing errors and things like that, but I think that's probably beyond the scope of this introduction. But generally speaking, think of the information as being added only in one direction. And so therefore, that helps to alleviate the concept of fraud, double spending, and some of these other things, because you can't go back and say, oh, I've got a branch of the chain that one looks one way, one looks the other, and they don't match. So if you go through those 4 steps, Once you've added the information, the chain is validated, communicated to all participating network nodes. Then the process repeats itself for the next block of data. Block of data is defined by the entity that's utilizing the chain of data. And this will make a little bit more sense as I tie some of these pieces together. Data blocks can include any type of digital information, for example, a list of financial transactions, change of ownership. If you think of home titles, so that's a slow-moving block, but you could have a listing of title changes that are through a block, or ownership of ownership of various things. So it gets communicated as ownership changed, block is added, or a transaction. For instance, if you have, let's use a better example. Let's say you're a factory that has a certain part that you might get from several different vendors. And so you want to be able to track where that particular part came from what particular vendor. It may have gone through 3 or 4 or 5 or a dozen different hands to get to you. You can track all that through a blockchain. So what is blockchain technology? The nodes are individual computers connected via the internet. Although in some instances you can have a closed network using the technology, which from a security standpoint may be just a way of duplicating data, as opposed to the open blockchain, where you're really one of the benefits is that you're utilizing data management capacity from others, rather than having to do it all yourself. And there's a security element to that, because you have a verified copy of that chain in the hands of many, many parties. And I'll get to the security issues on that in a second. So the security of the chain's accuracy is maintained by all participants having the same chain data once a new block is added. So that once the block has been added to the chain, then all the nodes can compare their copy of the chain to all the other copies. Inaccuracies can be immediately recognized and corrected by accepting the verified data. And then you've got verification of the data and accuracy of the chain, because you now have multiple independent witnesses that, these nodes are, think of them as witnesses, that are verifying, okay, this is the data chain, and now we move on to the next block, because now everybody's got the same information. So how does this kind of work together? Each node tries to earn the right to add the block by hashing. You may have heard the phrase hashing in regard to cryptocurrency generation. Hashing is basically not to be confused with the hashtag of Twitter, but hashing is a using a lot of computing power to solve a complex puzzle that the party that solves that solves that problem, it earns the right to add the next block to the chain. And their puzzles are trial and error. You can't back into the answer. So they go with the same concept of the one-way tracking of the chain, and you have to basically go through. That's why all the computing power is necessary to hash through the puzzle to earn the right to add the next block, because it's a super complex trial and error solution that is has to be found. And I'll get to that a little bit more also in the cryptocurrency part of this. But once that is solved, then that party gets to add the next block. They're compensated for it, and then the chain is verified. The information is spread out to all the other parties who are participating, and then the next block comes up. So this is my fine diagram of a distributed network. Each of the blue boxes represent a computer on a network, and this is just sort of the concept of, if this, let's see if I can, oops. Well, anyway, so you've got a series of all boxes on the network, the nodes. They're all interconnected. They may not be connected directly with each other, but the whole concept of the internet is there's interconnectivity here. So once the information is confirmed in one block or one node, it can be communicated across the network to everybody who's participating. So how does this work? The existing chain is communicated to the network by whoever the party is that's looking to track the data via this particular blockchain. And they create what's called block 0, the first block of the chain. Then the next puzzle is communicated to the network and that's you know, the parties are participating on a, I don't want to say a volunteer basis, but because there's compensation involved, and I'll get to that, but you know, they're not, if you want to apply your computing power to a particular blockchain task, then you can do it on a volunteer yourself and your computing power to do that. So the puzzle is communicated. The network nodes hash through the puzzle. First one to solve it adds the next block to the chain. Chain is verified across the network, and then the next puzzle is communicated to add the next block. And on it goes. I have a diagram here showing block 0, the hash puzzle. Block 1 is added, chain is verified to the rest of the network. Next hash puzzle is provided, solved. Block 2 is added, chain is verified, and on we go. So that, in very simple terms, using the chain of events, if you will, or the blockchain in creating the network or the distributed ledger. So how do, and this is kind of expands on that, blocks added by different nodes. So you've got two the green and the blue both have access to block 0. Blue solves the hash puzzle first, adds block 1, chain is verified, communicated, block 1 is communicated to the green node. They both have the same information. Hash puzzle is communicated, solved in this case by the green block, creates block 2, chain is verified, block 2 is communicated to the upper node, and back and forth it goes, but of course it would include many more parties than this in a normal blockchain scenario. How does it work? So the data is kept secure across the network through encryption, which is really the cryptocurrency, where cryptocurrency gets its crypto is the use of the phrase encryption. Keys are used to add and extract data from the chain. What are keys? Keys are digital signatures that are unique to the user that it needs to read the block of data. So, you know, you say, okay, I've got this data that I'm using a blockchain across a network of unknown parties to track. How the heck do I keep this stuff secure if it's got personal financial information or transaction information or intellectual property or various other things? And that's where these keys come into play, is they unlock the data from being nonsense to being usable data. So they're used to add and extract data from the chain. Keys are digital signatures that are unique to the user needed to, quote, read the block data. And to the nodes in the network, the data is meaningless nonsense if you don't have the proper key. So, you know, in some respects, you could think of it as your PIN for your ATM card. Your ATM card is useless to anybody else because they don't have your PIN. Or a mailbox in an apartment building, for instance. Anybody can put mail in, but if you don't have the key, you can't take the mail out. So that's sort of the concept behind the data keys. And so on this schematic here, you've got block 0 data on the left. It's encrypted with the input key. Becomes encrypted block 0. And then flash forward to however many blocks we have, block n at the end. And then finally, somebody who needs to read the data chain has the output key that allows them to read the data of the entire chain and use the data as they would want to use it. And all the parties that along the line that are doing the hashing and the tracking and all the work of the blockchain don't have any access to the data because it's all encrypted. So how does it work? Again, why do nodes participate? So the data to participate is available across the network, and if it's an open network, anybody can jump in. You're compensated for solving the hash puzzles by and adding to the chain. So if it's a let's say a party that if there's a party that's is using a blockchain technology to track something, and they're accessing the network to create the blockchain and keep it going, they will provide an incentive via compensation for those that solve the hash puzzles. And so by the incentive to run the puzzle and add the next block is a financial enumeration. And if you are incorrect and you validate an incorrect block, or you do something that's incorrect, there are penalties that are involved, so that disincents somebody to try to cheat on the blockchain or to create fraud. Participants are rewarded for finding errors, so that's where the cross-validation comes into play, because if everybody has to agree to the validation of the current state of the chain before it goes on to the next block. Hashing requires enormous computing power, so you have to really, another disincentive to cheat or create fraud is because you're burning up a lot of computing power to do the hashing. So you really need, the incentive is really there to do it for the reward, which is the last point. Required use of computing power dissuades attempted manipulation of the chain data, because it's just not, it doesn't pay to cheat. Crime doesn't pay in this case, let's put it that way. So purpose of the blockchain to create a data set that is accurate, verified, and secure. We've talked about the secure element and cross verification across the network. It's accurate by only allowing one defined block to be added at a time. Verified by other participants before the next block is added. So everybody has got the same information before the next piece is added. It's secure because once it's verified, everybody in the network has it. And so if you say, well, here's the chain, and it shows that I own this, and everybody else says, no, that's not the chain says this, it's easy to uncover the fraud or misrepresentation. Blockchain can be updated across the network instantaneously. So despite how complex these puzzles sound, with enough computing power, they can be solved relatively quickly. And so you can have a blockchain that becomes updated very quickly across the network, so that you've got the ability to manage transactions in a rather instantaneous fashion, or almost instantaneous fashion. And then auditing the chain is accurate and fast, because everybody's got a copy of it. It's digital, and everybody's, and it's been verified, and it's a chain of data. And there's a great example of this I've got coming up. So examples to use a blockchain would be payments and financial transactions, investments, loans, insurance, government documents, birth, marriage, death certificates, property titles, identification docs, or professional certification documents. contracts or patents, inventory, product sources. For instance, auto manufacturing example would be, let's say GM is sourcing a certain part from 4 different vendors, and they just discover that there's a defect in coming from one of the vendors. By using blockchain technology, they can trace back where that came from a lot faster than having to do it the old-fashioned way of tracing back through inventory sourcing. Food safety is another use of blockchain technology, which I'll provide an unbelievable example of that, I think, on the next slide. And 2 that I just actually added today, given what we're experiencing, the concept of using it for voting and perhaps contact tracing with the experience we're having with COVID, are both uses that could very well be solved with adaptation of blockchain technology. So Walmart, this is a food safety example. Walmart ran a test to see how long it would take to trace an individual mango from a single store to the farm where it was originated. And using their conventional supply chain tracing, it took a week for them to do that. When they used blockchain technology, it took 2 seconds. So you think about food safety, you've got, think of some of the romaine lettuce issues that we've had, or other issues with bacteria on produce, the ability to trace that back to the individual farm even, rather than saying, oh, you can't take any romaine lettuce from California. No, you just can't take any romaine lettuce from that farm in California. It makes a huge difference. And the time that you're able to do that can be very helpful in the fact that you can then know that it's safe to use the other 99% of the product from a given area, because now you know exactly where the tainted product comes from. So now we move on to cryptocurrency, which is really just a adaptation of blockchain technology. So what is cryptocurrency? Cryptocurrency is an electronic asset. Sometimes it's called digital currency, sometimes it's called virtual currency, sometimes it's called a digital token. It does not exist in physical form. It is not backed by anyone or anything, unlike government fiat currencies that we use, like the dollar and the pound and the euro, which is backed by central banks and full faith and credit of governments, hopefully. It's not backed by anyone or anything. It allows for transactions without intermediaries. So you can go through, you're paying somebody directly into their crypto wallet for something without having to go through a MasterCard transaction, a Visa transaction, a PayPal transaction, which goes through a bank, etc. So you cut out the intermediaries. As a result, it allows for anonymous transactions between total strangers anywhere in the globe. And the transactions are tracked via the blockchain. So besides Bitcoin, there are several others. Ethereum is another one, Tether XRP. I was really surprised when there's actually quite a list of different cryptocurrencies. Bitcoin is the biggest one is out there. Market value of Bitcoins as of 10/22, October 22nd, when I put this together, was $212.4 billion. Now, part of the notoriety of cryptocurrencies has been the use of anonymous transactions between strangers and dealings that have been transacted in things that would not be able to be transacted through legal intermediaries. So focus on the Bitcoin. It's a purely peer-to-peer version of electronic cash. Would allow online payments to be sent directly from one party to another without going through a financial institution. That's from the paper that laid out the original Bitcoin concept by Satoshi Nakamoto, who may or may not be a real person. Easy paper to find on the internet by just simply Googling Satoshi Nakamoto. Might be interesting read for those who have an interest in cryptocurrency. So how does it work? So transactions on how does Bitcoin? We're going to focus on Bitcoin here. Transactions are shared to the network and collected by all the participants in the network. Network participants collect the transaction, form the blocks. Proof of work game is going back to the hashing concept. Proof of work game is computationally solved. The winner gets to post their block of data as the next on the chain. Then the block is broadcast and verified by the entire network. The reward for proof of work and adding the next block is what creates new Bitcoins, and thus is called what they call mining. So the reason that some of these CPU farms have been put together in order to generate huge amounts of computing power to mine Bitcoins is so that they can solve the proof of work game that much faster, win more rights to create, or not to create, but more rights to add their block to the chain, and therefore be rewarded with the creation of new Bitcoins. So proof of work games provide equal chance of winning the right to post the next block. Computing power increases your chance of winning the block, and therefore the more computing power you have, the higher your chances, like buying more lottery tickets. Difficulty of the proof of work increases at intervals to slow the Bitcoin creation. So at certain predefined points, they increase the difficulty of these puzzles so that it slows down the eventual creation of new Bitcoins being rewarded for adding to the block or adding to the chain. Additionally, block rewards can be provided for block creators. So if a entity is using the network to track their transactions via blockchain, or a vendor wants to be added to a block, they can add an additional incentive to be included, to have their transaction included, which would be another incentive for the nodes to participate. And transactors can also add their own fees as an incentive to be in a block. So if you want to have your transaction included in a block, you can add fees as well. So there's a limit, actually a limit on Bitcoins. So the reward for creating new blocks is halved. So the reward that the reward that in Bitcoin that's paid by creating Bitcoins for those who are adding blocks is halved every 210,000 blocks. Maximum number of Bitcoins that can be created by mining is just under 21 million. So as of 20th of October, there are 18.5 million Bitcoins in circulation. Once all those have been created, the system is supposed to function strictly on transaction fees. So once the 21 million Bitcoins are out there, the concept is if you want to transact in Bitcoins, you're offering a fee to the network to generate and include you in the next block. Any questions? I tried to keep this at an introductory level without going too much into complexity of the computing stuff, which is complex. The sources I use to put this together are here, 3 books, and then the paper by Satoshi Nakamoto. And I'm happy to provide this slide deck to Beth, and then she could send it out to whomever may like to review it. So Beth, do I have any questions?
Thanks, Eric. So far, oh wait, question just popped up in the Q&A. What prevents bad data from being introduced to blockchain and then passed along and verified as bad data?
What do they mean by bad data?
Let's see if the person will type and answer your question. So what prevents bad data? Right, well, that would depend on what the definition of bad data is. Let's see if they type anything more in. Waiting for that. There's no other questions other than that. I did want to remind people that this program is being recorded. It will be available through the library's calendar. It usually takes us about a week to get it up. But at that point, if you go back to today's date, to the title of this program in our library calendar, you'll see a link there that allows you to watch this program at your own convenience whenever you want. I'm still not getting.
Okay, so.
He said, as an example, a rumor can be passed along as truth. Perhaps a financial transaction can appear valid when started.
Yeah, so if you go back to this slide, that's where the security keys become important, because the data in the chain is not readable to the network nodes and the block creators. So in order to put data in the chain, you have to have a key to put it in. It becomes encrypted. This is on a secure blockchain. It becomes encrypted, and to read the data, you have to have the output key in order to read it. So those that are passing the data along, if they don't have an input key or an output key to encrypt and unencrypt the data, it's just simply nonsensical coding or nonsensical information that they're passing along, because they can't decrypt the actual data that's in the system. I hope that helps.
Then can I sort of follow up? So then, as you said earlier, each time a block is added, the entire chain of nodes, everybody in the network, every node in the network sees the new completed chain and immediately verifies the new completed chain. So at each step, every time a block is added, it is re-verified and then re-verified and then re-verified by the entire existing network as it gets longer and more complex. So if anyone wants to put bad data in it somewhere along the line, wouldn't it be automatically noted by someone else in the network?
Yeah, because let's say you've got 10 blocks in the chain, and you add the 11th. So everybody's now going to say, okay, the node that adds the 11th block says, okay, here's the chain with 11 blocks. Everybody in the network knows what the first 10 were. So they say, okay, everybody agrees on the first 10, and this is the 11th. So everybody now says, okay, now we have a chain of 11. Here it is. The 12th block comes along, and it gets added by the party that earns the right to add it. Everybody looks at the 11 blocks and say, okay, we agree on those 11. This is the party that adds the 12. Now we have a 12 block chain that everybody agrees to. So that's how it progresses. I'm doing somewhat simplified, because believe me, there's in a couple of these books, there's whole chapters on how to go back and reverse transactions. But it's essentially, it's really a one-way chain. There are ways, they talk about branches and all kinds of other things, but from an introductory level, this is really what you want. The important part is everybody, once the block is added, everybody sees the new chain. They can verify that it's new, or that there is no link prior to there's no link in using my 10 block example. block 2, everybody, says, okay, block 2, we know what block 2 is. One party says, no, here's the chain. And everybody says, no, your block 2 is wrong. Your chain's not valid. Here's the chain. So everybody agrees on it that way. That makes
Okay.
sense?
Yeah, and then he has a follow-up question. How does one obtain the key? And I'm sure he means either your input or output key. How does one get an input or output key?
Well, those are created by those who are using the chain. Because you think of the nodes as simply being servants. They're providing computing capacity and security by cross verification and et cetera. The creator of the data has the input key, and the user of the data has the output key. That because they're the ones creating the data, the others are just tracking it, and what they're tracking on a secure chain is unreadable to them. So how can I just, so if you have, again, think of the post box. The mailman opens the post box with his key, and he can open it up and put all the mail in, say on an entire apartment complex, but only the apartment owner can open the box and take the mail out because they have the key. And it's kind of the same concept is without it's a decoding of the data. So it's created by the creators of the data and the end user of the data that have the keys to decode the information.
Using an example you used earlier with the PIN, is it kind of like you and the bank have both agreed on what the PIN is, but then all the middle people in between, when you make a financial transaction, they're not privy to that information, even though they're middlemen in the middle of the transaction between you and your bank. But you've both at the very beginning agreed at what that key is, but the people in the middle don't have it. Is that a fair analogy?
Yeah. I mean, think of analogy I was thinking of, which may or may not work. But let's say there's only 2 people in the world that speak a particular language, and you are adding pages to a book in that language, and different parties are adding pages to the book. And when you get to the end, the second person who speaks that language gets the completed book, and they're the only ones that can understand it.
Oh, that's a great analogy. So the people in the middle can add, but they're not understanding necessarily what they're adding.
Correct. They're given data to add, and they add it, but they can't use it. It's nonsense to them, because they're just, all you're doing is renting their computing power to create the blockchain.
I actually saw a headline, and this was months ago, maybe even more than a year ago, where someone was like sitting in a Starbucks. And this was back in the days when we could all just go sit in Starbucks whenever we wanted to for however long we wanted to. And they finally figured out that he was being one of these nodes in a chain, but what he was doing was he was somehow stealing computing power from all the other people sitting in that Starbucks with their laptops to try and create enough computing power so that he could be financially rewarded for being a node in the chain.
Oh, very tricky.
A new thing.
I know from talking to CPAs, for instance, that the concept of blockchain is something that they're very tuned into, or should be, because it could change the whole process of auditing. When it comes down to, go back to that Walmart example. Do you You track the mango for a week to figure out where it came from, or do you take 2 seconds? And if you think about, audit trails for transactions and inventory and various other things, if the blockchain becomes used across the board, all that information is now instantaneously available. And so you eliminate errors, you save time, and what they're more concerned about is you got to figure out something else to do to generate fees.
Well, and that's one of the reasons what little information I have of it is that it could potentially be quite, what's the word the economists like to use? Creatively destructive.
Right.
Because it's fundamental. It could be potentially fundamental in the way that the internet is fundamental. It is a platform that, almost unimaginable numbers of things can be created from or built on top of, that would then completely change how transactions happen because it's completely decentralized. We wouldn't need a bank anymore. We wouldn't need the CPA anymore. We wouldn't need all those middlemen, if you would, all those controlling institutions,
Mm-hmm.
because it could be done through blockchain.
Wouldn't need all those vote counters.
There you go. Yeah, so it could potentially change the world in the way that the internet changed.
If everybody had a unique input key that they used when they voted, and the data was tracked through a blockchain, and only one entity had the output key, then you could conceive of how this would be a way to alter voting to make it error-proof.
So young people now who say, well, why can't we just vote online? Which people of my age say, well, no, because then there's no paper audit. But if we use blockchain, then it would be secure enough where you could allow voting to just be digital, because it could be done in a verifiable, secure manner. Is that what you're saying?
Possibly, yeah. I mean, if you could verify that you're not fraudulently putting, if somebody doesn't walk in with a list of 1,000 input keys.
Right. All right then.
Well, think about it with fingerprints. Say, yeah, you can log on your computer with a fingerprint. What if you registered to vote by fingerprint? So there is absolutely no way that somebody could vote twice. There's no way they could vote for somebody else. It would be address a lot of issues that we happen to be living through right now.
Right.
And same with the contact tracing that I was looking at, thinking of, all these people we're hiring to do contact tracing for when somebody's exposed to COVID. Is that something, and I don't have an example of how it might work, but is that something that may be a use for blockchain technology?
Well, and not only the numbers of people who have to be hired, but the privacy issues as well. Because you wouldn't have that many potential leak spots where, private information could potentially get out. Kevin asked another question. He said, I was thinking like Madoff. Many people received fraudulent documents that looked real and were validated. If it started as fraud or incorrect in the blockchain, I'm assuming, Kevin, you mean ideally that the next nodes would invalidate it. So did you understand that?
Yeah.
Okay.
So yeah, that's a different. I have to think through because that's fraud perpetrated by the creator of the data, because money came in, he spent it on yachts and whatever, and falsified. But I suppose where it could really be, his situation could really benefit from something like this would be in the auditing of his financial transactions that supposedly backed up the returns he was getting for investors. So you'd have a lot more accurate and instantaneous ability to verify that, yes, the investments were there, the transactions instead of having a statement that said you own 1,000 shares of Apple, the whole transaction chain that created those, that ended up with those 1,000 shares of Apple in either your account or some other account would be verifiable. And so falsifying financial data that is, what he was doing is falsifying data to say, you've got $1 million in your account when you didn't. So the transactions that would back up the fact that that $1 million is actually there would be verifiable and provable via the blockchain. And it would be auditable instantaneously.
Yeah.
Whereas if you just had think of a ledger paper, whatever you write on it, as far as somebody else is concerned, that must be true. Well, just because it's it says you've got 1,000 shares of Apple doesn't mean you do. But if you can trace back the transactions and prove it through the chain, then you know it. Does that help?
So basically, you couldn't keep two sets of books.
That's correct.
Okay, so Kevin says absolutely. I'm assuming he meant yes, that helped. He goes on to say, that was my concern, that the creator started with fraudulent data that is then systematically validated based on referencing to the original lie or false information. So private industry like banks, governments, etc., would have to be participating nodes in order to validate.
Well, think about it, and go back to the Madoff example. So even his data would have started with a valid transaction, that being receipt of a wire, electronic transfer, or a check from a client. And so you've got actual data there that would be block 0, if you want to put it in this terms. And then everything that money is used for would be traceable through a verified blockchain from an original source of funds. Because where he created his fraud was taking the money and doing something else with it and just making up what he claimed to have done with it. Whereas with this, you've got the money coming in is data, and the money going out is also data in the chain. So it went out to buy 1,000 shares of Apple versus it went out to buy, his penthouse condo in Manhattan. So, those are all verifiable through the chain. And if you've got money coming in and it went someplace else, then that's immediately identifiable. Part of the concept of the blockchain is it allows for the a collection of immense amounts of data that's you think of all the data we create daily and kind of minute by minute, but it allows for the tracking of all that at a very granular level on an instantaneous basis, which then makes cheating and fraud that much more difficult, not impossible.
All right. Any other questions? I'm gonna give Kevin 20 more seconds to type something in. This has really been very interesting, Erik, and I want to thank you very, very much. Oh wait, didn't take him 20 seconds. Interesting stuff. Thank you. Do you expect data mining of Bitcoin to wane with only a few million left?
Well, it has to. I was actually going to pop up something I forgot. So let me figure out how to get stop sharing. Okay, let's see. Stop share. And then, okay. So what I wanted to do. So one of the reasons you would have Bitcoin, and I'm sorry I forgot to talk about this earlier, is sort of it's well, let's see, it's wrong page. Would be as a hedge against, say dollar devaluation, right? Same reason that you might have, let's see, yeah. So if you look at a chart of Bitcoin, because Bitcoin has a sort of a psychological variance to its price. So this is dollar price of Bitcoin over time, going back to January, go out to the maximum. You can see where it spiked back up in 2018, fell again, and now it's kind of going up again a little bit. You say, well, if people are using it for simply hedging against the value of other currencies, other fiat currencies, then you would expect it to have a relation to other things that might be used to hedge currencies like gold and silver, precious metals, if you will. And so if you track it relative to gold, let's see here, let's normalize. So this is from going back to the time period of commonality, which is 2014. See, gold hasn't really moved all that much. You get little blips here and there. And this is now percentage return, not dollar value per se. So if you bought, both of them at the same price here, this is how they've changed over time. You can see that Bitcoin doesn't relate to movement of gold any whatsoever. Now, part of that may be a factor of that it's notoriety, psychological, creation, etc. But when I look at why would somebody own Bitcoin, why would something that has nothing behind it go from a value here to a value up here? It's hard to explain from an economic standpoint. So I don't have an answer as to kind of what's going on with Bitcoin that makes its value what it is, except that somebody's willing to pay that price for it. So, but I thought that this chart was interesting because if you look at it purely as a dollar hedge for gold and silver, you see gold and silver kind of track each other pretty much close. I mean, relative to the Bitcoin. I mean, the return on from 2014 for gold has been 47%, and for silver has been 23%, and for Bitcoin it's been 2,550%. So, it's this obviously something different going on there than just simply a dollar hedge, which I found was kind of interesting.
All right, we'll give Kevin another 20 seconds if he has anything else he wants to ask. It's been very helpful, Kevin. We appreciate your questions very, very much.
Yeah.
Oh, yeah. Hold on. Let's see what he has to say. Future value speculations would be a big driver of current values like anything else, I suppose.
Oh, yeah. I mean, we all, being in finance myself, I mean, the future value expectations, present value of future value, present value of what we expect something to be valued in the future is how we price everything. So, when you look at, what's interest rates are basically the price of money in the future. What are you willing to pay or receive to get dollars later? And so it is a big economic factor. But I have to say, I've always found Bitcoin to be hard to put your finger on, and other cryptocurrencies as well. I mean, really, it's like anything else. It only has value if somebody's willing to accept it. So, if your $10 pizza is going to cost you 4 Bitcoins, then you know that your Bitcoin is 250 a piece. If it costs 1/1,000,000th of a Bitcoin, then you know your Bitcoin is worth 10 million. So it has to be a willingness to transact in that unit in order to give it any value whatsoever. And so, the vast majority of people still rely on currencies that are backed by central banks, governments, and things that we are all comfortable with. At some point, digital currencies may be more widespread and not as widely used for illegitimate stuff, which unfortunately a lot of it is not a lot, most of it, but a lot of it because it's untraceable. But right now it's early on, so it's a little hard to peg where it ultimately will end up. But it'll be, once they stop creating it, then it'll be interesting to see how it goes from that point when there's no new coins created and it's simply a trading of existing coins.
Kevin put in one last comment here. He said, kind of like electric cars. Maybe it's overheated, maybe not. I appreciate the information. I think it's in our future daily life for sure.
Yeah. Well, certainly the transactions with and the use of blockchain, I think, is going to be a much bigger factor. So, well, I appreciate everybody's time and the questions, Kevin. I found it very interesting in putting this together, and I'll pass the slide deck on to Beth if anybody wants it, for no other reason to see the resources I used if they want to check them out at the library if you have them.
Absolutely. And again, this has been recorded, so you can always go back into our calendar and find the recording. And thank you for being here tonight. Erik, thank you very much. I know this was, for those of you who don't know, this was it was a big ask that I had for Erik, and he stepped up and said yes, and he did this completely of his own free time. So thank you.
I know a lot more about blockchain than I did when you asked.
I think we all do. Thank you. And everybody have a really, really good night.